So just the general outline of what I'll be talking about. Talking about the real-time stream gauging monitoring, and just to let you know that stream gauge and river gauge, we kind of use that interchangeably. And in the USGS, we do spell gauge wrong. It's G-A-G-E, but we do spell it incorrectly in a sense. You will not find that word in the dictionary. So I'll go into how USGS stream gauges work, some of the instrumentation that's inside of it, and then I'll go over some of the data features, where can the data be found, and who uses the data. I will talk about flood inundation mapping, and then there'll be probably some time for some questions in the end. So what is a USGS stream gauge? It's a device that can provide continuous information on precipitation, surface water quantity and quality, or groundwater. We've been operating river gauges since the late 1800s, and the data is still readily available. It's obviously in book form, but it is still readily available. And across the United States, there are about 8,400 stream gauges or river gauges across the United States. In Ohio here, we operate about 320 gauges, and within the three-state area of Ohio, Kentucky, and Indiana, it's about 800 river gauges. So how does a stream gauge work? So if you look at the picture on your left there, that is actually a picture of an older stream gauge, but basically, and we've downsized since then. If you look to the right there, it's actually a small it's a small traffic control box now. But basically, you have some lines that go to the stream, and those lines are connected to a sensor inside the gauge house, and the sensors actually maintain. They sense the pressure, so if you have more head over a certain fixed point, those lines, that's the other important example, or important point is that those lines in the stream are fixed. They can't be moving up and down, or else you're not going to get a stable elevation. But the sensors inside the gauge house sense back pressure or lack of pressure. So it takes more work to maintain a certain pressure and voltage, so it interprets that voltage as a stage, whether it be going up or down. So inside the gauge houses, we also have a battery. The gauges are autonomous. We don't need AC power at the gauges. We have a battery, and usually on the top of the gauge house, there's a solar panel. And then you see the antenna there, and so data is available, and it's shot out to the satellite and available on the web on an hourly basis. So this slide here shows a more updated or better, I don't want to say better sensor, but a different sensor. And this is what we call a radar or a non-contact stage sensor. And so basically it just goes by time of travel. There's no silver bullet, okay? There's no silver bullet when it comes to sensing stage. Go back to my previous slide here. We have these lines that go in the river. And anytime you have a flood or something, those lines are suspect to getting knocked by debris. So you say, okay, I'll go to this radar, this non-contact stage sensor. So there's no contact with the stream or anything like that. But then what happens is you'll get a spider that sets up inside the radar cone, and obviously in the morning there's a lot of dew, and so the radar will sense that dew, and they'll think that that's the river stage, and that's not actually the case. The other thing with the radars is that for the northern states here, if you have an ice-covered stream, the radar does not sense an ice cover in the stream, so it'll give us really fictitious values. So there's no really one silver bullet when it comes to sensor. We just try to do the best we can given the situations that we have. So this is just a map of the real-time stream gauges in Ohio here, and you can look off of this, and you can pick any state your home state. You can pick any state that you want, but you can just eyeball the gauges and see that blue and black means that you're flowing a little bit higher. Green is normal flow, and any kind of dry conditions will show up as orange and red. And in this map here, it's mostly green. I think I took this back in July, and flows were within the 50 percentile. But if you click on any one of these dots there, you'll be able to obtain the flow information or the stage information from that site. And let me just backtrack a little bit. So On our gauges, we can also attach precipitation. We also have continuous water quality parameters that we can transmit as well, the 5 parameters at temperature, specific inductance, dissolved oxygen, turbidity, and pH. And also, we also have acoustic ADVM, acoustic Doppler velocity meter data. So what we do is we actually put a meter or a sensor in either the side of the stream or in the bottom, and it can actually sense real-time velocities in the stream in the X and Y component. So this slide here, stream flow is calculated from stage. So on a site that's stage discharge, stage is the basic parameter. The discharge that gets displayed on the web is basically calculated from the flow measurements that we make, and USGS, we maintain these stage discharge relationships. And really the only way to obtain or to get a stage discharge relationship is to continuously measure the flow, plot it on log paper, and then from there you can make your stage discharge relationship. This is, I believe this is Scioto River in Columbus here. And you can see the series of measurements that have been made, and then we plot those up, draw a best fit line. You can see on the top there, as you get into an overbank situation, possibly, you'll get more flow for a given stage, and so your slope kind of flattens out a little bit there. But for us, it's important to capture measurements at all ranges of stage so that we can adequately capture that stage discharge relationship. Now, the question is, do these things shift around? Yes, we redraw ratings. Things happen in the channel. You can imagine if you had a river channel and all of a sudden you had a large tree fall into the stream, that tree would obviously collect debris. Your flow would not change, but your stage would be backed up from that tree. So in a sense, you would have the same flow, but you would have a higher stage. On the other hand, and I saw this a lot in Missouri with a lot of sand channel streams, there's a lot of degradation issues, especially along the Missouri River. And the Missouri River is actually, the bed is degrading. So for a given flow, you'll actually have less and less stage. So yes, the rating curves do change over time. Nothing's stagnant in the water business, as we all know. And we do our best to capture that stage discharge relationship given the conditions that are presented upon us. But you see a gentleman making a measurement there. He's wading in stream. We actually have other tethered platforms that we call ADCPs that we actually go out and make measurements in the flow. But that's how we maintain that stage discharge relationship. So USGS data is available on an hourly basis, and it's near real time. So if a gauge collects data, and then we do collect it every 15 minutes, but that 12 o'clock reading will come within 7 or 8 minutes. That's updated on an hourly basis. So the DCP on the far left there, the gauge will collect the data. It'll shoot that signal up to GOES. From there, it'll go down to DAPS, which is a data processing system. That's in Wallops Island, Virginia. That's the one that we use on the East Coast here. And then from there, it'll kind of get decoded, sent back to a local satellite. And then from there, the local satellite will transmit it back down to a local ground satellite. And then it goes into our NWIS, or our National Water Information System. So this is the type of data that you see here for the stages, or for our sites. You see on the left-hand side the site name, the site number, and date and time. And then you'll see first gauge height. Again, gauge height or stage is the primary piece of data. The discharge off to the right is what is calculated. That is a calculated value, and then again, that's calculated from our flow measurements that we make And we go out every 7 to 8 weeks. My technicians go out every 7 to 8 weeks, make flow measurement, make sure that the gauge is working properly, make sure that the reference gauge is reading that the equipment on the inside is reading according to some reference gauge. It could be a wire weight, staff plate, an arrow on a bridge or whatever. But we go out and make sure that those readings are correct every 7 to 8 weeks. And then from there, I just pulled off Olentangy River near Worthington. You can pull off data. You can pull off your own statistics. That data is freely available on the web, and you can pull off daily discharges. You can pull off unit discharges every 15 minutes if you want to. Some of the data, I have to warn you, until it says approved, some of the data is provisional, but once it's approved, then it's pretty much set in stone. We don't go back, and there are sometimes we have to revise data, but it's 99% of the time. Once that data is approved, it's good to go. So I talked about NWIS Web, and this is the website there. And now this is just for Ohio, but you can go into any state that you can just type in, if you lived in Texas, it'd be TX instead of OH, or North Carolina, it'd be NC instead of OH. But you can go into this website here and pull off any kind of stage information. In Ohio, we have 14,000 sites, but you can pull off any kind of peak flow data. You can pull off groundwater measurements. You can pull off water quality. And you can pull off water use by county. It's just a wealth of information that's available at your fingertips, basically. And that leads into my next slide. So you can pull off, again, this is NWIS, and you can pull off your current conditions. There's many ways you can pull off current conditions. You can just get into USGS.gov and and you see a map of the United States, and you can pick your state. You'll be able to, once you pick your state, it'll bring up a map of the current conditions. You can get into it this way here. This here also has, historical data, but it's just a wealth of information. The website's on the top there. So I want to talk about Water Alert a little bit. Water Alert allows you to receive daily or hourly updates about current conditions in rivers, lakes, and groundwater. You can type in the conditions that are of concern to you. So you see on the bottom there, on the bottom right, what's circled there is a water alert. And so all you would have to do is go into the bottom right there, click that, and once you do that, you'll come up with this next slide here. Now this is for Scioto River at LaRue, but you'll come up with a subscription form. And we don't ask for a credit card number or anything. This is all free, okay? So you can pull up any site that you want. You can get hourly data, or you can get daily data. You can have it sent to your phone. You can have it sent via an email. And then what you would do is you would set in the stage level that you want. So I live in north central Ohio, and I have a river gauge Whetstone Creek near Mount Gilead, and it's about 5 miles away. And so I have it set to a stage of 12 feet. That's the flood level there. If you want to text if you set your parameters to a very low stage, you're going to get a text every hour. So I just set mine to the highest stages because I don't want to text every hour. But you can do that if you want to. And you can just any site that's of your concern to you, you can actually get in and you'll get a text every hour based on the stage that you want to submit in. So I'd mentioned about you getting a text message. You can also get an email message as well. And again, it's just one of the features that we have here at the USGS, and it's like I say, I have several sites in my phone that I really keep track of, and when I send techs out to measure flood waters, to measure flow, I have several sites in my phone that are very high importance. Some sites are very flashy. The smaller ones are very flashy. It's tough to get out there when you're 2 hours away. Sometimes you'll get an event and it'll be up and back down in an hour. So I have several sites on my phone that come in as a text. And yet you will get a text at 3 in the morning. So I mean, that's happened before. That you will get a text. And this is just a sample of the text message that you would get from Water Now. Okay, the next website is for mobile water. When you're traveling, you can, or if you're in a certain area, you can say, what are the nearest gauges 25 miles from my location? And so you can set that as a parameter, and it'll give you, the gauges within a 25-mile radius of your parameter. So that's another good feature. So who uses the data? The public is probably the biggest user of USGS data. I get a lot of calls from fishermen wanting, and if a gauge goes down, they'll be the first one to tell me. I mean, it'll be 7 o'clock in the morning when I come in. It'll be, I'll have a phone call. This certain gauge is down because they want to go out, fishing or whatever. But a lot of canoe liveries use our data as well. But that's on the recreation side. Getting more into the official side of things, the National Weather Service river forecast offices use our data. So anytime that you see a flood warning or a flood forecast for a certain point, they're using USGS river gauge data. And our stage data and flow data goes directly into the National Weather Service models and for use in forecasting stage and issuing flood warnings. And our stage is displayed on their AHAPS, or Advanced Hydrologic Prediction Service charts, along with USGS observed and a recorded stage. So you see the lower left there, the AHAPS. The blue is what's recorded stage, and that's from USGS river gauge. And then their forecast, whether it be, whether it's going to go into action or moderate or higher stages, is basically in, I think it's in purple there, but they'll be able to issue forecasts using our data. The interesting thing is it's kind of an interesting relationship, because when I'm sending out folks to flood measure, then I'll look at the AHAPS models to see where they're predicting crests. So they're using our data, and we're using the USGS, we're using their data as well. The Corps of Engineers also uses our data for gate operations on lakes, reservoirs, flood control, recreation. And then in Ohio, I have 4 core districts that I deal with. And then state and local officials, Department of Transportation, using it for road closures. I had a site in Missouri, Blackwater River, near Blue Lick, and they would know, they would basically look at a USGS gauge data. When it hit a certain level, the signs would come out, and they wouldn't even call. So you just look at our website, and then you go there to measure, and you talk to the state guys, and they'd be saying, "Hey, we really appreciate your data." So it comes in really handy. Flood inundation mapping, it's a web-based tool that shows the floodplain area of an inundation associated with USGS stream gauge readings. And its primary purpose is safety, lives and property here. So flood inundation, these are the sites here. In Ohio, we have Findlay, and we have Newark, Ohio. But Indianapolis was actually the first flood inundation model around, but we also did Blue River, Kansas City as well. So how are these libraries created? Usually there are streams in populated areas, and it's with an existing or new USGS real-time stream gauge. You've got to have a USGS gauge. And it also has to be a National Weather Service flood forecast point. And I'm going to fly through these next couple slides real fast, but to create these libraries, there's a wealth of data. You need LIDAR, you need the elevation data, or you need the study area, then you need the LIDAR, and historical data goes into it, and then we actually have models, and we calibrate models as well. And all that goes into this flood inundation depth grid, whereby we have these layers of flood inundation at certain river stages. So this is an example here. This is real time at Scioto River at LaRue. So at the action stage here, you know, this is what, and you can get down to the street level in this, but as far as the action stage, you can get down, it would display the action stage, but then if on this bar here, I don't have a pointer, do I? On the bar off to the, on this other chart here, there's a yellow, orange, and red, purple bar. All you gotta do is take your cursor and move it up. So I took the cursor and moved it up for Scioto River LaRue and moved it up into a major stage flood category, and this is what is displayed here. So some of these features here, you know, you can move your bar up and down based on a National Weather Service flood forecast if you wanted to. There's also some historical data that you can pull up, and then you can, on the bottom right there has the crests and peaks. The gap there means that the gauge was discontinued and then we reactivated it again. USGS is also on Twitter, Instagram, and Facebook. And then one question I get is, how does the USGS river gauge get started? There's a backbone of river gauges that we've operated for 100 years that Congress has directly allocated money for, but I don't get funding to put in gauges everywhere. So basically, local entity, city, local government, whatever, has a need, and we go into a cooperative agreement with them, with that agency or that entity. Sometimes there's cooperative matching funds that are available that I can throw into so that to ease the cost of, you know, installing one of these gauges, because there's a lot of instrumentation inside them, and we don't use just trolls or barrows, or, you know, we use really good equipment. And each state has a USGS office, and that is basically it. That concludes my presentation. Yes.
Yeah, what's your take on the future coming up for gauge technology? Is it going more towards non-contact, or?
Yeah, I think so. You know, we're getting these. Yes, we're getting these quick. You know, we're getting these droughts, and then we get these quick hitter events here, and they seem to be getting worse. And again, with my lines that go into the stream, it's just a kind of a recipe for disaster. They get, you know, if you're going to put something in harm's way, it's going to get taken out. Mother Nature is going to take it out. So yeah, we're going more and more non-contact stage sensors. I'd really like to see USGS get into smaller sensors and maybe some you know, little bit less expensive sensors, but that's beside the point. But yeah, we're getting into more and more the non-contact realm, because again, these events, as you saw in Ellicott City, Maryland, and these in central Pennsylvania, these are, you know, these are events that haven't happened. Somebody has mentioned it about Agnes, Tropical Depression Agnes. I remember Agnes, and these events are kind of blowing Agnes away. You know, and Agnes was the big deal in '72 for when I was growing up as a kid. And these events are even more, they're worse than Agnes was. So I do see that, yes.